Now that we have learned all about nuclear chemistry and radioactive decay, I wanted to show you some more practice problems on how to calculate half-life so that you can do some more independent practice problems. So this is your equation from half-life. So be sure to go ahead and add this to your equation sheet. So it's m sub f equals m sub I times 1/2 raised to the power of n. Okay, your m sub f stands for your final mass. M sub I is your initial mass, and this will usually be in grams. And then the n stands for the number of half-lives. Okay, all right, let's look at some practice problems. The first one, I'm going to use this equation directly. Fluorine 21 has a half-life of 5 seconds. If you start with 25 grams of fluorine 21, how many grams would remain after 60 seconds? Okay, so like we always do, let's analyze this problem and see what we know. Okay, we know that 1 half-life is equal to 5 seconds. We know that our initial mass, or the beginning mass, is 25 grams. Our final mass is our unknown. This is what we want to calculate. And we know that the total time is 60 seconds. Okay, so the first thing that we have to do is we don't have an n. We weren't provided with that n. So we have to figure out the n, or the number of half-lives. And we do that by using the total time and the time of 1 half-life. Okay, so we take our total time, 60, divide it by 1 half-life, which is 5, and that gives us 12. That's our n. That's the number of half-lives that we waited. So 60 seconds is equal to 12 half-lives of fluorine 21. Okay, now we can just plug numbers into our equation. Okay, and solve for our final mass. So our initial mass is 25 and our n is 12. And then we just pop this into our calculator and get our final answer. Now you want to be careful. Make sure you do the order of operations correctly. If you just type this into your calculator, it likely will give you the wrong answer. You want to make sure that you do 0.5 raised to the 12th first, then multiply that answer by the 25 to get your final answer of 0.0061 grams will remain. If we double check our sig figs, we see that 5.0 has 2 sig figs, 25 has 2 sig figs, this 60 has 3 sig figs. So since 2 is my least, my answer needs 2 sig figs. Okay. So this is using the proper equation to complete these activities or these types of questions, but we can also break it down in a different way if you prefer, so I'm going to show you that method next. How much of a 20-gram sample of sodium-24 would remain after decaying for 30 hours if sodium-24 has a half-life of 15 hours? So break it down. What do we have? What do we know? We have a total time of 30 hours. We have 1 half-life is 15 hours. And we know our original mass is 20 grams. We want to know our final mass. Okay, so the first thing I need to do here is say, well, how many half-lives do I need to go through? So this is similar to what we did before, where we are going to figure out the number of half-lives by doing the total time, 30 hours, divided by 1 half-life is 15. 30 divided by 15 is 2 half-lives. Okay, now this time, instead of using the equation, what I can do is just manually do the half-lives, the number of times that I need. So if I start with 20, I divide it in 2. That gives me 10 grams left after 1 half-life. I then take that answer, 10 grams, divide by 2 again. and get my 5 grams remaining. That is after 2 half-lives. That's as many half-lives as I needed, so I have 5 grams of sodium-24 remaining. Okay. This way I think is easier when we need to solve the problem not for the final mass, but for time. So let's look at an example of that one. How long would it take a 100-gram sample of sodium-24 to decay to 3.125 grams if sodium-24 has a half-life of 15 hours? Okay, so what do I know? I know that my total time is what I don't know. That's my x. That's what I'm solving for, is how long would it take. I know that 1 half-life is equal to 15 hours. I know that I started with 100 grams, and I know that I ended with 3.125 grams. Okay, so what do I need to do? Well, first I need to figure out how many half-lives. Okay, so either way we're working this problem, we always got to figure out how many half-lives first. So to do that, I'm just going to do real simple, keep dividing by 2 until I get to the final. So we start with 100, divide by 2, that's 50 grams. That was 1 half-life. I'm not to 3.125 yet, so let's do it again. 50 divided by 2 is 25. I've gone 2 half-lives. Got to keep going. 25 divided by 2, 12.5. Now I've gone 3 half-lives. Still not down to the smallest mass that I need yet, so keep going. 12.5 divided by 2 is 6.25. I've gone 4 half-lives. I'm still not there yet. 6.25 divided by 2 is 3.125. I have gone 5 half-lives, and I am at my ending mass. So it took me 5 half-lives. Okay? Running out of space here, so I'm going to put this on a new slide. What I'm going to do is move that number of half-lives I had to go into my given, into my known column, so that I can solve for how long did it take. Okay, and all I have to do is say, well, I went 5 half-lives, and 1 half-life is 15, so I do 5 times 15. It took a total of 75 hours for the sample to decay from 100 down to 3.125. Okay, so these are the 2 skills that you're going to need to do in your practice problems. You will need to say how long did it take a sample to decay, and you'll need to be able to say how much will be remaining. So just like the 2 examples I gave. If you don't know how to do this, you don't understand the process, get into contact with me. I will be happy to help you out.